Okay. Hi, everybody. Happy Friday. So, today we're gonna talk about session 9.1. Yeah, we're behind schedule. It's okay. Hopefully, we can catch up later. So, yeah, 9.1. Yeah, we talk about 9.1 today. Uh, okay. So, last time we talked about improper integral. You still remember? The either the one of the limit of integration is infinity or minus infinity or both. Okay. In this case, we have improper integral. If the integral is easy, where you can use some direct formula to compute, then you can just set a limit t, which one is the improper value, and then integrate that function, and then plug in the t, and then see what's your answer. If you get a finite number, then we say the integral converges. If you get infinity or minus infinity, we say the integral diverges. But if your problem is harder like this, then I think it's better to do the indefinite integral so you don't have to carry the limits every step. You know what I'm saying? Yeah, after you figure out the antiderivative, then you can compute the definite integral and you set the limits t goes to infinity. Okay? And then this one is also U substitution. So I compute the indefinite integral and then plug in the values. I think in the practice exam of practice exam 2, let me see where I can find it. Practice exam 2, because the in-class examples, both of them are U substitution. I wonder if I show, yes, the practice exam example. This one, instead of using U substitution, I use integration by parts. So it's kind of similar. You use integration by part, and you find the antiderivative, and then you plug in the limits of integrations. You let the t goes to infinity. But here, there is a tricky part here. Because you're not only having the numerator, you have your numerator and denominator, they are both function of t. But then in this case, you have to determine which function goes to infinity faster. Imagine you have numerator and denominator. If your numerator grows faster, then the fraction it goes to infinity because your numerator grows faster. But if your denominator grows faster, what happens? It goes to zero. Exactly. So when you have your numerator and denominator, they're both function of x, you have to determine which one grows faster. Do you know exponential function grow faster than all the polynomial? Exponential function like this, polynomial function like that. So exponential function grows super fast. Therefore, the denominator grows faster. So this fraction goes to zero, and you get a finite number in that case. Okay, so yeah, your practice exam has an example of integration by parts. I think this one is also U substitution. So yeah, only two harder methods, either U substitution or integration by parts. Okay. So let's continue. Capital value. So the capital value of an asset is of an asset is often defined as the present value of all future next earnings of the asset. The accumulated present value of a continuous money flow into an investment at the rate of $F per year, perpetually. It means forever, is given by the following. So this formula, we suppose f is a constant function. That's why you don't see f of t. So this formula is assuming your f is a constant function. Okay? And how do we get this? Okay. And yeah, you remember our formula of the present value? It was 0 to t and then f of t e to the minus rt dt. Yes, do you remember that? And now it says forever, forever. So you let the t goes to infinity. And here you assume the f is a constant function, right? So f is just a number, a constant function. You have a fixed amount of money flows each year, continuously. Okay, and then 0 to infinity. So how do we compute this? This is the limit t goes to infinity. And because f is a number, you can pull it outside. Okay. You know what? Abuse of notation. My variable is t, then don't call this t again. Let's use a different letter. Which letter do you like? Any letter not t? Z. Z? Okay. So, and e to the negative rt dt. So this is limit z goes to infinity. And now, how do you integrate e to the negative rt? E to the negative rt over negative r. Right, everybody? Yeah, now evaluate from 0 to z. Okay, so let me continue here. So it's limit z goes to infinity, and we have f over negative r. You plug in z, so e to the negative rz minus, we plug in the t is 0. Yes, everybody? Now, exponential function looks like that, but you have the z goes to infinity, your minus rz goes to negative infinity, so e to that it goes to 0, right? So e to the minus rz goes to minus infinity, and that's why this guy, it goes to 0. And what is e to the 0? 1, exactly. Therefore, we get f over minus r times negative 1 is f over r. That's why we get this number, f over r. Everybody clear how we get this number? Yeah, you don't have to like memorize this number. You can just like integrate. Then you get that. Okay, example 2. Determine the accumulated present value, i.e. the capital value, for investments for which there is a potential continuous money flow of $2,400 per year at the interest rates of 6.5% compounded continuously. So in this case, we have F is 2,400. Yeah, that's a fixed amount. And R is 6.5%, which is 0.065. Is that okay, everybody? Okay. So now we get the capital value. So it's 0 to infinity, 2,400 e to the negative r is 0.065 t dt. Now that equals to f over r. So we already show why we get f over r. So now we just plug in f over r. Let me give you this. Okay, so use your calculator. What is 2400 over 0.065. Zero 76. Oh, okay, then 08, like that. If it's to the decimal places. Okay, thank you. Okay, that's the amount of money. Everybody clear? Mm-hmm. Okay. So, but be careful. This formula is true only if f is constant. If f is not constant, then you actually need to integrate. What is the integral, and then let the z goes to infinity. Everybody clear? Mm-hmm. Good. So that is 8.4. So we finished chapter 8, and now let's go to chapter 9. So remember your exam 2, it covers chapter 8, which is 8.1, integration by parts, 8.2, the applications, the functions, and the average value, 8.3, the continuous income stream, the present value, the future values, and 8.4, improper integrals and the capital value. That's chapter 8. And then it also covers chapter 9, section 9.1 and 9.2. Okay, now
the practice exam 2 already up.
Yes. I think I have all the practice exam up. Yeah. Okay. So let's see. 9.1 is here. Okay. So now we finish the 2-dimensional. We go to the space 3-dimensional. Okay. So functions of several variables. So count 1, function of a single variable. Now count 2, functions of several variables. The xy plane is often called R2 because the coordinate is x and y, and there are the real numbers. So R2. The 3-dimensional space is often called R3 because now you have x, y, and z coordinates. So before this class, you study functions of the form y equals f of x. Such a function, the input is a real number and the output is also a real number. So we usually say that x is the independent variable and the y is the dependent variable. Your y depends on x. Right, everybody? Okay, now how about a function of 2 variables? So now we have a function from R2 to R. So R2 is x and y. Okay, so a single function y equals f of x. We have the x coordinate, the y coordinate, and your function like that. Right? This is a single variable function. But now f from the xy plane to r. So you get z. See? Z equals f of xy. The input is an order pair. The output is a real number. So how do you draw it? Okay, so you draw the 3 rays like that. And this is the x-axis. This is the y-axis. This is the z-axis. And then for every point on the xy plane, you plug in f, and you get a height, a z. So z is the height of this. Is that okay, everybody? Imagine every point, and you plug in it, you get a z is a height, and then you kind of get a surface. You imagine you get a surface on the xy plane. So function of 2 variables can be described numerically using a table, or graphically, you can draw it, or algebraically, use a formula, or in English. Okay, so let's see example 1. The cost of renting a car depends on how many days you keep it and how far you drive. Makes sense. Have you ever rented a car?
Yeah.
Yeah, the vacation? Oh, yes. Okay, so let D be the number of days you rent the car, and let M be the number of miles you drive. Then the cost of the car rental is a function of the two variables. Look at the table. You see, D is the days. It could be 1 day, 2 days, 3 days, 4 days. And M is the miles you drive, 100, 200, 300, 400. Oh, so this is the table. So what is the cost of renting a car for 3 days and driving it 200 miles? See? 3 days and 200 miles. And you get this number, $150. Right, everybody? So you can write this is the cost where the day, let me see. Okay, so we do the days first. The cost of 3 days and 200 miles equals $150. Let's say, if it's dollars, the unit. And part B. What is C of 104 and what is C for, 100? Okay. So C, something wrong with it. Okay. C 104. This means it's 100 day. Yes. And 4 miles.
Oh.
But is it on the table? No. So not in the table. Okay. And C for 100. So, see, 4 days and 100 miles, which is what? Yeah, $175. So far, so good? Yeah, so the order really matters. What's your first coordinates? What's your second coordinates? They mean different things. Okay, so part C. Suppose we rent a car for 3 days. Is C an increasing function of miles? What does that mean? We look at the column. Oh, sorry, the row. Okay, we look at the row of 3. Okay, for 3 days, and look at the numbers: 135, 150, 165, 180. Do you see the cost is increasing when your miles increase? Mm-hmm. Then we can say the D is fixed, which is 3, but the M varies. So then this is a function of one variable. So this is a function of one variable, which is the M, the miles. And it is an increasing function. Because SM increases, our cost also increases. Is that okay, everybody? Mm-hmm. Yes. So it has 2 independent variables. If you set one of them as constant, then you get a function of a single variable. Then you can use all the knowledge we learned so far, and you can determine whether it's an increasing function or decreasing function. And sometimes you can also find the maximum or minimum of it. Remember how we find a maximum or minimum of a function of single variable? We take the derivative, find the critical points. And if your function is increasing and decreasing, this is a local max. If your function is decreasing and then increasing, that is a local min. Exactly. Okay, any questions about example 1? Okay, let me make sure the recording. Okay, good. So I'm worried that it locked me out of my recording. Okay, so generalize the idea. We can have functions of more variables. So in this picture, you see the input we have x, y, z, w, and the output is one variable. Okay, so this f is actually from R4 to R. We're not able to draw them in space because in space it's R2 from to R. But R4 to R, you need 5 dimensions to draw that. So we're not able to draw it. But we can evaluate. So f of 0, 1, 2, 3. The x is 0, right? So 35e to the 2x. X is 0. What's w? 3. Minus 7. What's z? 2. Plus square root of what's y? 1. And z is 2 to the 4th. Right, everybody? We plug in different numbers. And we get 35. What is e to the 0? Oh, yes. So 1, 3 minus 7 half plus what square root of 1 plus 3? 2. Oh, so 2 times 2 to the 4th. Okay. What is 35 times 3? 105.
Yeah.
Minus, this is 3.5. What's 2 to the 5th? Yes, a 32, right? So this is 101.5 plus 32. Is it 133.5? Yeah, everybody? Okay. So this is example 2. We just plug in the numbers. All right. So now it's time to draw the graph. Okay, so how do we draw the graph? You have a point, that's the origin, and you draw 3 rays. This is the x, that's the y, and that's the z. And how do we plot the location of the point? So how do you do it? You look at the x, and then so you imagine you are walking. You are standing at the origin, and look at your x. You go to the positive x-axis. How many units? And then you look at your y. You go to the positive y directions. How many units? And then z is you go up how many units. So this is how you draw it. Okay, now let's draw it. So draw another one here. Okay, that's the x, that's the origin, that's the y, that's the z. Oops, sorry. I don't mean to erase it. Okay. Give me back my line. Okay. Hey. Huh? It freeze. Okay. All right. That's Z. Okay. So now we have the X is what? 4. So we go 1, 2, 3, 4. Yeah. We go to the X direction. 1, 2, 3, 4. What's the Y? 3. So we go to the Y direction. 1, 2, 3. Yes, everybody? So we're sitting right here. What's the Z? 2. Negative 2. So what do? We go down 2 units. So which is this point? So this point is for 3, and negative 2. Is that okay, everybody? Okay, we continue. How about the next point? Bless you. X is negative 1. So what do we do? Negative 1 here. Yeah. And then y is what? 7. So go to the positive y direction. 1, 2, 3, 4, 5, 6, 7. Like here. Yes, everybody? And then do we go up or down? Or go up? We go up. How many units? 3. 1, 2, 3. Oh, right here. So this is negative 1, 7, comma 3. Is that okay, everybody? Yes. So in this chapter, you're gonna draw pictures in 3D. Do you like drawing pictures? Yeah. Okay. So now, let's draw the plane x equals to 5. Let's draw another graph. I don't want to draw too many things on one coordinates. Okay, so we have the x, y, and z. Okay, x equals to 5. So x is 5. You go to the x direction, 1, 2, 3, 4, 5, right? So let's say this is 5. And it's a plane. So can you imagine it's a plane? It crosses the x-axis at 5. So you can draw a plane like that. It's a plane. It crosses the x-axis at the 5. But your y direction can be goes to infinity minus infinity, and your z direction can go to infinity minus infinity. So you get a plane like this. It's perpendicular to the x-axis. Okay. How about you draw the plane y equals 2? How about you draw the plane y equals 2? How do you draw it? Okay. Let's see. Do you want me to draw at the same grid or different one?
Same grid.
Same. Okay. So let's do that. Okay, y is 2. So 2 is here. So you can imagine it's a plane that, well, let me draw it like this. It crosses the y-axis at this point. So it's perpendicular to the y-axis. Okay, everybody? Yes, so use your imagination. Okay. So I also suggest that you can use GeoGebra as an online free software. So in this or Desmo, yes. So if you here you change to what? Where is it? The 3D. Okay, 3D graphics. And then now let me don't draw this. And let me draw. Okay. Let me see. Oh, okay. So x equals 5. Yes. Let me make this one. Yeah, you click this and then or here you click dot. You can choose the 2D graphic or 3D graphic. And now but their x is here and their y is here. So if you want to, you can move it around. So it looks like ours. We always have x here and y here and the z there. Now you can see the plane. This is the plane x equals to 5.
That helps a bit more.
And
So
y equals.
Z is basically like piercing through the x and y axis going
Yes.
that way.
Right.
Okay. That makes a lot more sense than the triangle look to it.
Oh, yep. Uh-huh. So yes, so this is the y equals to 2.
So it's basically a fish tank.
Oh yes, right. Is that okay, everybody? Okay, so this is why I draw those 3 arrays. Okay, yes. So this is a 3D picture. And now let's do harder ones. How about the plane 5x minus 7y equals 35? Which axis is this plane parallel to? Okay, do you all know linear function in the xy plane is a line? Yeah, linear function in R2 is a line. Linear function in R3 is a plane. Okay, so let me write it down. Linear function in R2 is a line. Linear function in R3 is a plane. Okay, and let's draw this one. Okay, so we have the 3 lines, okay? X, Y, and Z. Do you see this equation has no Z in it? Right? It has no Z. It means it does not care what the Z is. So it is parallel to the Z axis. Okay? And let's draw this guy on the XY plane. So on the XY plane, if we let x equals to 0, you get minus 7y equals 35. Yeah, everybody? And what's your y?
Y is going to equal
You mean negative 5?
negative.
Yes. So y equals negative 5. And then how about we let y equals 0? We get 5x equals 35. X is 7. So on the xy plane, it's gonna pass through, see the first point, x is 0. And then the y is negative 5. And on the xy plane, your z is always 0. Imagine your xy plane is here. Your height is 0. Yes, everybody? And also pass through the points where the x is 7, the y is 0, and also on the xy plane, the z is also 0. Is that okay? Now we plot them. So x is 0, y is negative 5. Okay, let's say this is negative 5. And the z is 0. So it's this point. Or the other point, the x is 7. Let's say this is 7. But the y is 0. And the z is 0. Yes, everybody? So this is a line on the xy plane. Now, you want to draw this guy in space, is going to be like this. Sorry. Let me make this better. Okay. It's going to be a plane like this. It passes through this line, and it's parallel to the z-axis. Because this equation has no z. So no matter what the z is, it doesn't matter. Okay? So that's why it's parallel to the z-axis. The z could be anything. And yes, so this is the picture of this plane. You all finished the picture? Yeah, let's draw the plane using GeoGebra. Okay, so 5.
What's it called?
Yeah, GeoGebra. GeoGebra. GeoGebra.
Okay.
Yeah. So GeoGebra. So 5x minus 7y equals 35, right? Okay, let me unclick those. Do you see? This is our picture. Yeah, so this is the picture of that. And you kind of can rotate it and you can see better. Okay?
So we can use this on the test, right?
No, you cannot use your computer on the test. Okay. So now let's do harder ones.
Wait, you said we can use.
You cannot.
No.
You cannot use your computer.
I'm just trying to think.
You just have. Come on. You just have 50 minutes.
Yeah.
You have a lot of problems to calculate. Yeah. There's no time for this. Okay.
I could solve every single thing in 50 minutes. I could solve every single thing.
Okay.
That's why I'm not allowed to use it.
Yes. All right. How about it's a linear function, right? So it's gonna be a plane. It has all the three variables. So therefore, it's not like a plane parallel to any of the axes. It's not gonna be parallel to any of the axes. So do you remember how many points we need to fix a line? 2 points to fix a line. Then how many points can fix a plane? Three. So if you.
Oh yeah, because Z still. Z
Yeah, it
zero.
can rotate.
Okay.
So
Yeah.
you need 3 points to fix a plane. Okay. So 2 points fix a line, and 3 points can fix a plane. So to draw the plane, we need 3 points. Usually, we want to see where the plane intersect the x-axis, y-axis, or z-axis. So we find the x-intercept. So x-intercept is we let y and z equal to 0. And we solve for x. Let's do that. So ax, y, and z is 0. Oh, what is x? Six?
Sorry.
3? Yes, 3. So x is 3 and y and z are both zeros. Okay, how about the y-intercept? What do you let to be 0? The y-intercept, what is 0? Yeah, z will be 0 and
So this is Y.
yeah, very good. So the point is 0 for 0.
Is Z the easiest to set to 0, or is it like the standard form?
Okay, so for x-intercept, then you only look at the x-axis.
Mm-hmm.
All the other variable are zeros. So, and because here we need 3 points, we will find all the intercepts. The x-intercept, y-intercept, and the z-intercept. So here the z-intercept, we let what? Yeah, sorry, x and y equals 0. What do we get? Yes. Then what is z? Yes, 2. So what's the point? Yeah, wonderful. Okay, now are you ready to draw it? Let me see. Okay. Let me make it better.
So you kept this on the test because this is way easy, right?
Huh?
This seems like really simple.
Yeah, so I won't ask you this on test.
Oh, okay.
This is just help us to understand the basic.
Okay.
We're gonna do fancy stuff, calculus on it.
Okay.
Yeah.
So we're gonna integrate to get x, y, or z.
Not integrate yet.
Okay.
In the next exam, you integrate, but this exam just derivative for the space. Yeah. Okay. So now the first point 3 0 0. So 3 here. That's the first point, right? Everybody. And 0 4 0. 1 2 3 4 here. And then the other one is 2. Okay. Can you see those 3 points? And now we connect them. Can you imagine it is a plane like that? It cut over there. So if you can draw something like this to indicate it's a plane, and it cut those, it intersect those 3 axes like that.
So is it a triangular plane or?
Oh no, it extends forever. But when we connect the lines, you can see better how it crosses.
Can you plot it in Geo?
Oh yeah, sure. And can you also see this plane? It crossed the XY plane in this line, and it crossed the XZ plane. This is the XZ plane in this line, and it crossed the YZ plane in this line. Yes. Okay, so let's draw it. AX plus 6y. So AX plus 6y, and then what? Thank you. Equals 24. Okay, this is the picture. How do I? Okay, so this is X, and this is Y. Why the X and Y flip? Okay. I can't use my fingers now. Okay, so this is the plane. X, Y, and Z. And this is a plane like that. Can you imagine, everybody? The blue one. Yeah, the blue one. Okay, so if you want to draw the point, see this is a point, this is a point, and this is a point, this is a point. Like cross like that. Okay. Okay. So this is plane. Alright. Any questions about example 5? Okay. So, alright, let's go to the next one. The graph. Now the graph of a function f of xy is the set of all points xyz for which y equals f of xy. Each input variable is assigned a coordinate axis in space, and the output variable is assigned its own coordinates. Usually draw the z-axis is the vertical axis, and then your xy is on the horizontal xy plane, and the z up there. So in general, we visualize such a graph as a surface in the space. Okay, now other ones is not just plane, it's surface. How do we draw them? Okay, the first one, you get z equals x squared plus y squared. Okay, everybody? So now it needs you to be familiar with some of the basic functions like parabola, circle. Do you feel that it looks like a circle? Because what's the standard form of a circle? The x squared plus y squared equals r squared, right? This is a circle centered at the origin with the radius is r. Do you agree, everybody? So how do we draw it? Okay, we have x, y, and z. Now, do you see if we plug in z is 0? If z is 0, you get x squared plus y squared equal to 0. X squared is greater equal to 0. Y squared is greater equal to 0. If the sum of those two things equal to 0, it means both of them have to be 0. Right? So we got the origin, x equals y equals to 0, which is the origin. So when z equals to 0, we get a single point. How about when z equals 1? If z equals to 1, what happens? You get x squared plus y squared equals to 1. Can you imagine what is z equals to 1? Z equals to 1 is a horizontal plane. And on this horizontal plane, this surface intersected at the unit circle. So unit circle, I can draw something like that. Yes, this is the point when z equals to 1. Z is 1, and it's parallel to the xy plane. So we get a unit circle. And when you draw such pictures, you try to plot integer points. So you see what I'm doing? I'm looking at the possible values for z. Can z be negative? For real numbers, no. No. So the smallest z is 0. So we get a single point. And I increase the values of z. And z is 1, it's like that. And increase the values of z. See, if z is 2, oh my goodness, it's not integer point, right? Because your r squared here, if z is 2, your radius is square root of 2. It won't be an integer. So let's keep increasing the z until we get integer for the radius. What z do you think is the next number? 2. 2? 4. Yes, 4. So we go to the 1, 2, 3, 4. 4. So when z equals 4, we get x squared plus y squared equals to 4. It's a circle with radius what? Radius is 2. Can you imagine, everybody? Radius is a 2. So on this plane, z equals 4, we get a circle, but with the radius is 2. So now we have a bigger circle. The radius is 2. Radius is 2. Mhm. And now you connect them together. We get a paraboloid. So this is called a paraboloid. Can you imagine, everybody? Ah. And yeah, so this is how to draw it. You look at how the function look like, and you can see, oh, with different z, this looks like a circle. So we pick different z values, we draw some circle, and we connect them, and you can see this is the surface. Now let's use GeoGebra. So GeoGebra, we have z equals x squared plus, oh, see, the x squared is just a parabola and it's parallel to the y-axis, and then plus y squared. Yes, this is the paraboloid. Okay, parabola, and then 3D is paraboloid. Okay, and circle in 2D, in 3D is gonna be sphere. Yes, ellipse in 2D, in 3D, ellipsoid. Yes. Okay. All right. Let's continue. How about part B? Do you see part A and part B kind of similar? That you have a square root there. Yes, everybody. We have a square root there. So let's do the similar things. By the way, because it's square root, you see your z is always greater or equal to 0 because it's square root of something. The smallest is also at 0, right? The smallest is 0. It passes through 0, 0, 0. Okay, now let's see. We can see when z is 1. Okay, you see, we can plug z is 1, and you get square root of x squared plus y squared is 1. So x squared plus y squared is 1. You also get a unit circle there. Yes, everybody? But the next number, by the way, this is the same as z squared is x squared plus y squared. Yes. So the next number, instead of 4, now I can pick 2. Because x squared plus y squared is 2 squared. So at 2, we get the circle. with radius 2. That circle here is at the height of 4. So now this function, the height is 2. So when you connect them, you see it's actually a cone. It's not ellipse. It's not a parabola. It's a cone. So when you draw it, can I do so? Z equals square root sqrt if you want to put square root, and then you have x squared plus y squared. Do you see we get a cone? Yes. So we will do more examples next class. Okay. Next class also print out 9.2. Okay. If we finish, yes. We were supposed to talk about 9.2. Yeah. Okay. So next class print out 9.2. Have a good weekend.